Hey folks, good morning, good afternoon and good evening to all of the attendees based on your time zones. And in today's session, we'll be comprehensively learning about the concepts of data mining, and then we'll have a case study where we'll be implementing these data mining concepts with Python. Now, before I start off with the session, just let me know if I'm audible and if you guys can see my screen, and if everything is fine, we can proceed with the session. Also, in the meanwhile, I'd like to state that we have launched a free learning platform called Great Learning Academy, where you'll have access to almost 100 courses with respect to domains such as data science, artificial intelligence, digital marketing, cloud, and a lot more. All of these courses have been curated by industry experts who have their masters or PhDs from Ivy League schools. And once you complete these courses, you will have a certificate which you can go ahead and add onto your LinkedIn profile or onto your resume, which will be a huge value add to you guys. And also, if you want to learn through an app, we have the Great Learning app as well. You can find the link for both Great Learning Academy and the Great Learning app in the chat over here. And to folks who are new to our YouTube channel, I'd request you guys to hit the subscribe button and also click on the bell icon, as it will encourage us to come up with more such live sessions, and also it will notify you whenever we have the new live session scheduled and whenever we upload new videos. And since everything is fine, all of you have given me your confirmation, let's proceed with the session. So this will be the agenda for today. We'll start off by understanding what exactly is the need of data mining. Then we will look at the data mining life cycle. After that, we will look at some of the machine learning algorithms, and finally we'll have a case study with Python. Now, before we understand the concept of data mining, I'd like to ask, what is data? Could you let me know in the chat what comes to your mind when you hear the word date? So, data is just collection of facts, isn't it? So, whenever you look around you, we are surrounded with data. When you're working with numbers such as 23, 8000, minus 18.76 or 3.45, all of these numbers are just data. When you say statements such as this is Sparta, I love pizza, or Joey doesn't share food, all of these again constitute data. Then data, it's not necessary that the data has to be present in the form of numerical format or text format. Your data can also be present in the form of images and videos. And especially in this time of social media boom, if you go to Facebook or if you go to Instagram, millions of people are uploading millions of pictures every single day. And when we talk about video data which is present in the video format, so right now what you're consuming is video format data. When you go to YouTube or when you go to other streaming sites such as Netflix, Hotstar or Amazon Prime, you are consuming video data. So data is present everywhere and it is present in all formats. But why am I telling you about all of these different types of data? That is because the data which was present back around 20 to 30 years is totally different from the data which is present now. So the data which was present around 2 to 3 decades was small and structured. Now, what do I mean that the data is small and structured? So back then, data was present in kilobytes, not even megabytes. So around 30 to 40 years back, data was only present in kilobytes. And if you guys remember, we had something called as a floppy disk. And as far as I remember, the maximum size of the floppy disk was only 512 KB. That was the maximum storage space of a floppy disk, only 512 KB. So you can understand that this is the only short amount of data that you can store. And also, the data was very structured back then. Now, what do I mean when I say data was structured? It was mostly present in either numerical or textual format, and also it was mostly present in a tabular format. It was mostly tidy data. And since data back then was very small and data back then was very structured, you didn't have to perform any sort of analysis to find information. So 20 to 30 years back, there was dearth of data, there was lack of data. But right now, exactly when we talk about today, there is no dearth of data. Data is being produced from multiple sources, and we have huge amounts of data. We have petabytes and exabytes of data. So when you compare this contrast from kilobytes to petabytes and exabytes, this is an explosion of the data. And right now, this data is unstructured. Now, what do I mean this data is unstructured? This basically means that data is present in other formats except tabular data. When you talk about images, when you talk about videos, when you even talk about XML data, all of this is unstructured data. And since we are sitting on top of all of this data, we have to do something with it, isn't it? So now we have this data, but if we don't do anything with it, if we don't try to analyze to find out more information, then we are just the biggest idiots in the world, because this data can solve a lot of problems. Now, if we properly use this data, and if we properly apply data mining concepts on this raw data which we have, it can help to boost a company's revenue. It can help a company to reach more target audience. And right now, if you are in this period of lockdown, many data scientists and many machine learning engineers are actually trying their best to stop the spread of this virus called as COVID-19. So there are a lot of things with which, there are a lot of things which can be done with the help of data mining, and that is what gave birth to this field called as data mining. So now that we know what is the need of data mining, let's actually look at some data mining use cases. So there's this very good example over here, and this is from the banking industry. So let's say you're just sitting at your home, and let's say you're actually living in Australia, and one fine day you get a message from your bank stating that you have spent 10,000 Australian dollars on buying a diamond necklace in the United States. But the problem is, you've never been out of Australia and you never spent more than 5,000 Australian dollars in your life. So here your bank has immediately flagged this transaction as a fraudulent case. So someone from the bank, some telecaller from the bank would have called you up immediately and asked you if this transaction was actually performed by you. And how did the bank know that this might be fraudulent? Because the bank uses a lot of data mining techniques to understand how you do these transactions. And when your bank keeps a track of your transactions, it would understand that you stay in Australia, you never spent more than 5,000 Australian dollars ever in your life, and you've never been to United States. So that is why one fine day, when there's a transaction from your account of buying a diamond necklace in the United States for the cost of 10,000 US dollars, your bank immediately recognizes that this might be a fraudulent case, and someone from the bank would call you and ask you if this is actually a transaction done by you. So this is a very good use case of data mining. Then we have another use case where we have Gmail. So I believe all of you have Gmail accounts, and in your Gmail accounts you'll have separate sections, isn't it? You'll have one section where you will have all of your regular emails, then you'll have one tab for your promotions, then you'll have another tab where you'll be getting all of your spam mails. Now, how does Gmail tag it as a spam or a promotion or a normal genuine mail? What is happening over here is Gmail again is using data mining techniques at the back end. Now, whenever you receive a mail, so a mail consists of a subject line and also body. And when you receive a mail, these data mining techniques are used to understand the text. So let's say if the subject line is, "Congratulations, you have won a lottery of $50,000 and there are 10 exclamation marks followed by it." So here Gmail immediately has some sort of data mining techniques which would recognize that. So let's say if there are more than 2 exclamation marks in the subject line, then it would tag it as a spam. Or maybe let's say if it would, if the subject line would consist of words such as jackpot, congratulations, you have won something, or maybe Prince from Dubai wants you to invest in his company. So if the subject lines are sort of like this, then Gmail would automatically tag it as a spam. And in some cases, we users also help Gmail. So Gmail is also collecting data from us. So let's say if I'm regularly getting a notification from some insurance to buy maybe a life insurance policy, then what I can do is I can tag it as a spam. And if 10 more people like me go ahead and tag life insurance as spam, then the 11th person in the 11th person's folder, if he gets a mail from LIC, it will automatically go into the spam section because 10 people have already tagged it as spam. And this is how data mining technique is being used over here. So we have looked at some basic use cases. Now I'll just go and take up some questions. Gnanesh Raj is asking me to tell the difference between data mining and machine learning. Sure, I'll cover that. So we've just started off with data mining. I'll also tell you what exactly is machine learning. We'll definitely cover that. So just wait for 10 more minutes. We'll have you sorted over there. Gyaneshwar is saying data can be all the real work we do daily. Absolutely, Gyaneshwar. So whatever we are producing, whatever is out there on the social media or anywhere on your laptop right now, what you have, all of that is data. Right, so I don't see a lot of questions over here, so I'll take up the rest of the questions later. If you have any questions, put them up in the chat, and I want this session to be as interactive as possible. So if you attended my earlier sessions, I make sure that I parallelly also take up your questions. So keep your questions coming, I'll take them up. So Radhakrishna, Jitendra, Gnanesh, I'll take up your questions about the difference between data mining and ML in another 5 minutes, because I also have the topic ML covered in this. And after that, if you don't understand, I'll come back to this question. Datta is asking what is KDD in data mining. So KDD is basically this data mining life cycle. So KDD, the full form is Knowledge Discovery Database. So this Knowledge Discovery Database is essentially data mining life cycle, and we'll be covering that right now. Praveen is asking, is data mining related to web scraping? It's actually the opposite. So you can consider data mining to be the superset and web scraping to be a subset of data mining. So data mining is mining of any sort of information. And when you talk about web scraping, it is mining of information from websites. So web scraping is a subset of data mining. Moin is asking, is data mining and data manipulation the same? So here again, data manipulation is a subset of data mining. So as you see, this is the entire data mining life cycle, and data manipulation would come under this particular part. Roshan will be covering KDD. So this, what you see, is also the KDD process. This is the data mining life cycle. Avnish is asking which is the best data mining tool. So I personally prefer R for a lot of data mining techniques. So I'd recommend you guys to use R if you want to perform any sort of data mining. Right, so I'll take up the rest of the questions later on. And again, if you haven't yet registered to Great Learning Academy, or if you don't know what exactly is Great Learning Academy, you can go ahead and check that out. You will find the link of Great Learning Academy over here. Right, so now that we have understood the need of data mining, let's go ahead and understand the data mining life cycle. So here, we would have to start off by acquiring the data. Then we'd have to pre-process the data. After that, we'll apply some machine learning algorithms, and that will give us a result. Once we get a result, we'd have to evaluate how is the result, and finally will show out the result to our stakeholders or to our client. Now let's start off with the first part, which is data acquisition. As I've told you guys, data is present in multiple formats and we've got huge amount of data, and all of this data is coming from multiple sources. So data can be present in the form of a PDF, in the form of Excel file, in the form of a Word doc, in the form of an image, or in the form of video. Now, let's say if the problem statement is something like this. You're working for a telecom company and most of your customers are churning out to a rival company, and you'd want to understand why is that happening. So this is the problem statement. So what you'll do is you'll collect all of the data. So there is this universal data related to all of your customers. Now all of that data could be present in a lot of formats. So you'll collect that and you'll store it in one single place, and you'll call that one single place to be a data warehouse. Now once you store all of that data, you obviously can't perform data mining technique or data mining operation on top of this entire or the superset of data. So what you'll do is you'll only take what is known as the target data from this universal data. Now this target data would depend on your problem statement. So here my problem statement is, I want to understand if my customer will stay with me or will he move out. And if that is the case, I'd want to take only that particular data which is relevant to this particular problem statement. So let's say data such as whether my customer is married or not, or what is the age group of the customer, or what is the gender of the customer. These might be something which might actually affect if the customer stays with me or not. So I'll only take relevant data and I'll call that relevant data as target data. Now once I've acquired the target data, I can't again go ahead and directly build the data mining models on top of it. Why? Because the data which I have with me is extremely raw. It is extremely untidy. And that is why I'd have to pre-process my data. And what is pre-processing? Pre-processing is just making sure that my raw data is converted into a tidy format. It has correct information. It has no outliers in it. It has no incorrect information in it. And for that, once I make sure all of these basic stuff is done, there are two more subcategories in data pre-processing, which are data manipulation and data visualization. So here, data manipulation helps us to find some easy insights from the data. So let's say if your manager one fine day comes to you and asks you to find out. So let's say if your company has around 2000 employees, and your manager comes to you and asks you to find out all the employees whose salary is greater than $100,000 and whose age is greater than 30. So now you have this huge Excel sheet of 2000 rows, and maybe there are 100 odd columns. So would you actually manually go through each record, check the age of the employee, also check the salary of the employee, and verify if the age is greater than 30 and the salary is greater than 100,000? Well, that will actually be stupidity on your part, and that would be a huge waste of your time. Now, instead of investing all that time, what you can do is you can apply some simple data manipulation operations, and these can be done with languages such as R, Python and SQL. All you have to do is write in one line of command. Instead of manually going through the entire Excel sheet, the entire tabular data, all you have to do is write in one line of code and you will get this insight. And this is data manipulation. Then we have data visualization. Now, similarly, let's say if your manager just shows you this huge Excel sheet which has maybe 1 million rows and 1000 columns and asks you what are the insights from it. Obviously your mind will be blank because this is just raw data. There's nothing in it. It's just a tabular format with lot of text and lot of numbers in it maybe. So how will you find out insights from it? Now instead of showing you the textual data, what if I actually show you a geometry? So what if I show you a bar plot or a pie chart or maybe a histogram? So if I actually show you a pie chart instead of the tabular data, you'll be able to find insights more easily. You'll be able to understand what is happening in this data in a much more better manner. And this is this is where data visualization comes in. And this part in a data scientist role or in a data analyst role, this is the major task which you will be performing. So 50% of your time will be going into pre-processing, because if the data itself is wrong and you build your models on top of your incorrect data, you will obviously get incorrect information. So you'd have to make sure that the raw data is correct, and only if your raw data is correct, that is when you will get correct information. And when you're starting with incorrect data, there is 100% probability that you will definitely get incorrect information. So this is about data pre-processing. Now, once we have acquired the data, after that we have pre-processed the data and we have tidy data, then we can finally go ahead and build our machine learning models on top of it. So what are machine learning models? These are just intelligent algorithms which would help us to find information from the raw data. So we will go ahead and build these machine learning models on top of our raw data. So we have different algorithms for different purposes. So we can build classification algorithms, regression algorithms, or clustering algorithms depending on the problem statement, and these algorithms will give us a result. Now, once we get that result, there is a good possibility that the result again is incorrect or the result is inaccurate. So here we'd have to evaluate our result. So this is where pattern evaluation comes in. So this is known as a 3-number check. So here we'd have to ensure that the information which we get after applying the ML model, that information is correct, that information is new, and that information is also useful. So if all of these 3 parameters are checked, that is when we can go ahead and say that our information can be, it is actually what we want. Now, if we know that we've got the correct information from the machine learning model, we can directly go ahead and show it to our stakeholders, and this is where knowledge representation comes in. So in knowledge representation, we just show it out, we just use different visualization methods or different BI tools to show the result to the stakeholder or to the client. So this is the entire data mining life cycle or the entire KDD process. So I'll take up some questions now. Tamila NDA is asking, my questions, pie chart, bar and this kind of stuff are used for different scenarios, right? Yes, absolutely. So all of these visualizations have different purposes. So let's say if you are building a scatter plot, then a scatter plot is used to understand the relationship between 2 numerical entities. If you are building a bar plot is used to understand the distribution of a categorical variable. Similarly, if you are building a histogram is used to understand the distribution of one single numerical entity. Raghav is asking which ETL tools are used mostly in the industry. When it comes to ETL, it is again for all of this, the entire data mining life cycle. Right now in the industry, the 2 most preferred languages are Python and R. So all of this ETL operations can be done with Python and R. Rohit is asking me to explain pattern evaluation once again. Sure, I'll do that. Now, when you build these ML models, you'll get a result. So I hope this is clear till now. We build these machine learning models, we get a result, and once we get the result, that result can be inaccurate, and most of the times it is inaccurate. So here what we'll do is, let's say if we build a classification model and if we build a decision tree model and we get maybe a 60% accuracy, then what we'll do is we'll go back, we'll make some modifications, we'll tune some hyperparameters in this decision tree model, then we'll build the decision tree model again. Then let's say from accuracy of 60%, if the accuracy goes to 65%, then this will mean that the second model is better than the first model. Now we'll try again if the accuracy can be improved. So instead of building a decision tree model, I'll maybe go ahead and build a naive based classifier. So this time if I use a naive based classifier, I might get an accuracy of 70%. And if I want to improve the accuracy again, so this time instead of building a naive based classifier, maybe I'll build a random forest classifier, and with the random forest classifier I'll get an accuracy of 85%. So this is an iterative process where you'll try to get the best information or the information which is most accurate, and this process is pattern evaluation. So I hope that answers your question. Nishant is asking, almost every ML model is data pre-processing step. So is data mining a part of ML algorithm? It's the opposite, Nishant. So as you have seen over here, applying of these ML algorithms is a part of the data mining life cycle. So also you can call the same thing as the data science life cycle as well. So as you guys see, the entire data mining lifecycle comprises of these particular steps, and applying of machine learning algorithms is one stage of your data mining lifecycle. Joseph is saying EDA is exploratory data analysis. It is analyzing the data that we have mined. Yes, that is absolutely correct. So EDA is basically this stage over here, data pre-processing part, where we apply data manipulation and data visualization operations on top of our data which we have mined. YA 2021 is asking, is EDA part of data manipulation? Again, it's the opposite. Data manipulation and data visualization constitute EDA. Right. So I'll take up the rest of the questions later on. You can post your questions over here. And guys, if you haven't yet subscribed to our channel, hit the subscribe button and also click on the bell icon. It will encourage us to come up with more such live sessions on a regular basis. And also, if you have any more suggestions on what sort of topics we'd have to take live sessions on, you can put them in the chat. We will note it down, and we'll have those live sessions arranged. And also you can share these live sessions with your peers or with your colleagues so that they can upskill themselves during this period of lockdown. So we have looked at all of these. Now we'll look at a classic data mining task which is known as anomaly detection. So anomaly detection helps us to identify unusual patterns or outliers in the data. And outliers cannot be present in the data because it will skew your entire information. And this is a very good example over here. So let's say there's this particular pub or a bar where the average salary of all of the people who go to that pub or bar is around $100,000. But one fine day, Jeff Bezos decides to go to that particular pub. So on that day, the average salary of everyone who goes to that particular pub would shoot up from $100,000 to maybe $1 million, isn't it? So here, Jeff Bezos would be the outlier and he is skewing the right data. So if Jeff Bezos would not have come to that pub, the average salary of everyone who attend or go to that pub would be around $100,000. But just because Jeff Bezos showed up to that bar, the average salary shot up to $1 million instead of staying at just $100,000. And that is why outliers are bad to your data. So whenever there are outliers present and whenever there are extreme values present, you have to make sure that either you remove them completely or maybe you try to reduce the effect of this outlier on your entire data. Then we have another interesting data mining task called as association rule mining, and this method is used for finding interesting association among different entities. And here there's this very good example of association rule mining which is known as the beer diaper syndrome. So it's a very interesting name, isn't it? Beer diaper syndrome. So there's this research or a case study done by Walmart around 15 years back, where they wanted to understand the purchasing pattern of all of their customers. So they were just monitoring, what their customers bought. So there they found this very uncanny relationship that if single dads ever came to Walmart to buy diaper for their kids, they'd generally buy a can of beer along with this diaper. Now this is very strange, isn't it? Single dads coming to Walmart to buy diaper for their kids also buy a can of beers along with it. So this is a very strange relationship. Now normally you wouldn't be able to find out this relationship, but with the help of this data mining task called as association rule mining, Walmart was able to find this out. So these are just some interesting techniques which you can apply to find all of these uncanny relationships in data. So after finding this out, what Walmart did is they decided to stack diapers next to beer bottles, and somehow the sales of diapers also increased and the sales of beer cans also increased. So this is what most of the stores or supermarket use for cross-selling or upselling items. Right, so that was all about your data mining life cycle. Now we will head on and understand what is machine learning. And we have this very simple example again to understand machine learning. So here, what do you see? This is a fish. Now what exactly is this? This again is a fish. And this, well, this too is a fish. And now, how do you know all of these are fish? Well, as a kid, you would have been, you would have been told that this is a fish by your kindergarten teacher or your parents, and your brain learned that whatever looks like this is actually a fish. And once your brain learned about this, whenever it came across a real life fish or maybe an image of a fish, it immediately understood that this actually is a fish, and that is how our brain functions. But what if I had fed all of these different images of fish to this machine? How will this machine be able to understand that this actually is a fish? So this is where machine learning concepts come in. So here what I'll do is, we'll use the same concept where we had reinforced this concept of fish into our brain. So here we'll take millions of images of these fish and we'll keep on feeding these images to this computer until it learns all of these features associated with this fish. And once it learns all of these features associated with the fish, I'll give it a new data or the test data to determine how much it has learned. And if it has learned properly, if the training is done properly, then it will be correctly able to tag that this image is of a fish. And maybe if the training is not done properly, then maybe it will tag this image as a dog or a cat or maybe something else. So this is the underlying concept of machine learning, where we first train our model with a lot of data. Once the training is done, we will give it new data or test data to determine how much it has learned. So that is about machine learning. So again, if you have any questions, you can go ahead and put them. I'll take them out. Rohit is asking, he's confused between R language and Python, RETL. Simply put, ETL is just one particular stage. ETL stands for extract, transform, load. Now, this extracting data or transforming data or loading data can be performed by any tool. So R and Python are just languages, and with these languages you can perform ETL operations. Now let's say if I want to extract data from a database. So if I have a database at the back end and if I'm coding through Python at the front end, what I'll do is I can connect Python with SQL, and when I connect Python with SQL, I can extract data from the database, pull it to the front end, and then I can write whatever Python code I'd want to do. Similarly, now I've extracted the data. If I want to transform the data, then I will use libraries such as pandas or numpy to convert them into a data frame or convert them into arrays and then apply some simple operations on top of that. Prashant is asking me to give an example of speech and text data. Sure. Text data is anything which is written in textual format. So when we are implementing web scraping is an example of text analysis, because what you're extracting is textual data. Now, similarly, let's say if we are doing sentiment analysis of maybe Twitter data. So let's say we have to mine everything that is present on Twitter with respect to one particular topic. This again is textual data. Then if you want me to give an example of speech, so let's say we can take examples of all of these chatbots, all of these virtual assistants. You have Siri, Cortana, and Google Assistant as well. Now, when you ask Siri, tell me the distance between Earth and Moon, this is speech, isn't it? You are speaking something which is in natural language, and this virtual assistant is able to understand this speech data. So Darshan is asking me to list the step by step on how to learn ML. Sure. As I've been always stating, so these are the three pillars which you would have to master when it comes to machine learning. The first step needs to be statistics or math concepts, because statistics and math form the fundamentals of all of your machine learning topics. So here what you will do is so here you'd have to start off by understanding the basic statistics. Let's say you'll have to start off by understanding measures of central tendency, then you learn about measures of deviation, you'll learn about central limit theorem, then you'll head on to probability, you'll learn about conditional probability, then you'll learn about different probability distributions. You'll have Poisson distribution, Gaussian distribution, normal distribution, and so on. So you learn all of these. So once you're good with stats and probability, then you can head on to a programming language. The next pillar is programming language, and I'll recommend you guys to learn both Python and R, because both of these are equally relevant in the industry, and depending on the project you will be either choosing Python or R. Now once you're done with stats, once you're done with both of the programming languages, then you'll head on to the machine learning concepts, where you will learn all of the underlying concepts, the math of all of these ML algorithms. You'll learn comprehensively about linear regression, logistic regression, decision tree, random forest, Naive, SVM, and all of these different algorithms. So I hope that answers your question, Mohammed. Supriya is asking what is the difference between data encapsulation and data mining. So these are two totally different concepts. Data encapsulation comes in the object-oriented programming side of things, where you only show information that is relevant and you hide all of the information that is irrelevant. So that is data encapsulation. But when it comes to data mining is, simply put, you would want to find out information from your raw data. Again, I'll take up the rest of the questions later on. So we'll move on. We'll head on to this session over here. And again, guys, if you haven't yet subscribed, hit the subscribe button and also click on the bell icon, as you will get all of the notifications of our upcoming sessions, and it will also encourage us to come up with more of these live sessions on a regular basis. And we'll also be glad if you spread the word of mouth about great learning to your peers or your colleagues, as they can also upskill themselves during this period of lockdown. And if they go ahead and register to Great Learning Academy, all of your peers, all of your colleagues can be certified and upskilled during this period of pandemic. So now that we've understood what exactly is machine learning, let's look at the different categories of machine learning. So we have supervised learning, unsupervised learning. We also have another category called as reinforcement learning, but we'll not touch upon that in today's session. So we'll only look at supervised learning and unsupervised learning. So when it comes to supervised learning, we will have input variable and output variable. This input variable is denoted with X and the output variable is denoted with Y. And we try to understand the relationship between Y and X. Or in other words, we try to understand how does Y change with X. Here again the input variable will be your independent variable and output variable will be your dependent variable. And the nomenclature is very intuitive, isn't it? Because we call this dependent variable because Y or the value of Y is dependent on the value of X. And we try to understand as and when X changes, how does Y change along with X? So this is supervised learning, and in supervised learning you would also have to keep in mind that your data is labeled. And in supervised learning we have two categories, which are regression and classification. We'll start off with the first one, which is classification. So classification is the process of predicting the class of a new variable. And here we have another good example. So we are trying to classify whether a patient has cancer or not on the basis of whether he smokes. Here, whether the person smokes or not, this will be your independent variable, and whether the person has cancer or not, this will be your dependent variable. And on the basis of this, I am trying to understand whether this person has cancer or not. So I am trying to classify. It's a classification process, isn't it? So I'm trying to classify whether I can tag this person as whether he has cancer or whether he doesn't have cancer. A very simple example of classification. Next, we have something called as a regression, which helps us to estimate the relationship between different entities. And I'll just give you guys an example of a linear regression. So, sure, again, in linear regression, we'll have a dependent variable and we'll have independent variable. Now, let's say we map the independent variable on the x-axis, we map the dependent variable on the y-axis, and we have the x variable basically denotes the CGPA of a student and y variable denotes the GRE score of a student, and we are trying to understand if there's a relationship between the CGPA of the student and the GRE score of the student. So when we collect all of this data, we sort of understand that there is sort of a linear relationship between the CGPA of the student and the GRE score of the student. Or in other words, if the student has a higher CGPA, then it is likely that the student will also get a high GRE score. Now, where linear regression comes is to answer questions such as, let's say, if I ask if the CGPA of a student is 8.32, what will be the GRE score of the student? This is where linear regression comes. So now, let's say if CGPA is 8.32, and if I draw a line from here to this regression line, and if I draw a horizontal line from here to here, then I will understand that if the CGPA is 8.32, then the GRE score would be somewhere around 315. So these are the sort of questions which can be answered through this linear regression. So that was classification, and regression was about supervised learning. Now we'll learn about unsupervised learning. So here we have all of this data. So we have data in the form of cars and data in the form of bicycles. But you have to understand that all of this input data doesn't have any class labels associated with it. Now, even though there are no class labels, I am going ahead and building this unsupervised learning model on top of this raw data. And when I build this unsupervised learning model on top of this raw data, I get two clusters. The first cluster comprises of all of the cars, and the second cluster comprises of all of the bicycles. Now, you'd be thinking, if there are no class labels, how is this algorithm able to divide these two into these clusters? And this happens on the basis of similarity of the data points. So here there are two things to keep in mind. One is known as intra-cluster similarity, the other is known as inter-cluster dissimilarity. So if you look at all of these data points over here in this cluster, you would see that all of these are cars, which would mean that all of these data points are very similar. So we have high intra-cluster similarity for all of these cars. Similarly, we have high intra-cluster similarity for all of these bicycles as well. Now, if you look at the data points between these two clusters, you would see that these data points are very dissimilar. So these cars are very different from these bicycles, which would mean that there is high inter-cluster dissimilarity. Now, this unsupervised learning algorithm was able to divide this entire data into these two clusters on the basis of similarity of data. And here what we did was implemented a clustering algorithm, and this is the underlying concept of unsupervised learning. So this is all about machine learning, the categories of machine learning. I'll just go ahead and look at some questions, and if we have time, we'll head on to the case study. Ujwala is asking me to take this session in Hindi. So right now this session is in English, Ujwala. So if you want to know when are our Hindi sessions scheduled, again you can go to Great Learning Academy. So there there you will know when our Hindi sessions are scheduled. Mohammed is saying NumPy and Pandas are used for descriptive analysis while sklearn is used for predictive analysis. Yes, that is right. Ansar is asking what is the difference between factor analysis like EFA and clustering. So that's a broad topic, so we'll cover that in some other session. Since we are also limited on time, we only have 10 minutes and also have to look at the case study, and we haven't yet started that, so we'll have that covered in some other session. Rohit, sure. So we have a couple of tutorials on R already, and if you want an advanced session, so we'll have an advanced session on tutorial ready for you. Prachi, I'll be going ahead with the practical right now. I'll start it. So we have covered all of the theory. I'll be starting with the practical. Great. So most of you folks are asking me to start off with the case study. I'll go ahead and do that. And before I go ahead to the case study, again, if you guys don't know about Great Learning Academy, if you haven't yet checked it out, it's a free learning platform where you'll have almost 100 courses with respect to different domains such as artificial intelligence, cloud computing, data science, stats, and a lot more. And all of these courses have been curated by industry experts. And once you complete these courses, you will get a course completion certificate, which you can go ahead and add onto your resume. So you can check out the link for Great Learning Academy in the chat. And also, if you want to learn through an app, you will also find the link for Great Learning app over here. And again, if you haven't yet subscribed, go ahead and hit the subscribe button. And if you haven't yet clicked on the bell icon, also do that, so that you will be notified of our new live sessions, and also you'll be notified whenever we are uploading new videos. So as of now, we have around 3 to 4 live sessions scheduled every single day. So you can also share these live sessions with your peers or with your colleagues, so that you also have a group learning atmosphere. You can learn collectively, and also you can spread information to everyone. So you can spread all of these high quality tutorials to everyone, so that they can upskill themselves during this period of lockdown. Great. So now that we have cleared all of this, let's go to the demo part. So we'll be having a case study where we'll be implementing different data manipulation and data visualization operations on this census data frame. So we'd have to start off by reading this data frame, and for this purpose I'd have to use pandas. So I'll load pandas, then I'll load this file. So to load the file, I'll have pd.read_csv and I'll store it in this object called as census, and I'll have a glance at the first 5 records of this data frame, which you see over here. Once I load this data frame, I would have to look at the shape of it. So shape of it just tells me the number of records and the number of columns which are present, and this tells me that there are 32,561 records and 15 columns. So let me just go ahead and import the required libraries. So I'll have import pandas as pd, and then I'll just go ahead and read the required file. So the name of the file was census.csv, and I would have to store it in a new object called as census. And when I load this data set, I'll have a glance at the first 5 records of this data frame. And to have a glance at the first 5 records, I'll use the head method, and these are the different columns which are present over here. So I've got this age column which would tell me about the age of this person. I've got this education column which would tell me if this person is a high school graduate, a college graduate, or maybe a doctorate or something like that. Then we have the marital status, then we have this race, then over here we have this native country, what is what is the native country of this person, and then we have this income column which should tell us if this person's income is less than $50,000 or greater than $50,000. Now let's also have a look at the shape of this. So I'll have census.shape, and when I hit on run, you would see over here that I have 32,561 records and 15 columns. Now that I have loaded all of this, let me just perform some basic operations on top of these. So here I am trying to find out the minimum age and the maximum age. So it seems that out of all of the people who are listed in this data frame, it seems that there's one particular person who has the minimum age, and that person's age is 17. Then obviously there'd be one guy who will have a maximum age, and that person's age comes out to be 90. And if you want to find out the average number of hours these people work, so out of these 32,000 people, it would seem that on an average these 30,000 people work around 40 hours per week. Then similarly, it seems that there's one particular guy who works around 99 hours per week. So let's implement all of these over here. So I'll give in the name of the data frame over here. I'll give in parenthesis, and if I want to find out the minimum age value from this entire data frame, first I'd have to pass in this age column over here. I'll just give in age, and if I want to find out the minimum value, I'll use the min method over here, and when I hit on run, you would see that the minimum value over here is 17. Similarly, if I want to find out the maximum age value, I'll have census. Again, I'll pass an age inside this. I'll use the max method, and this time when I hit on run, you would see that the maximum age value is 90. And if I want to know the number of hours worked by these folks over here, I have this hours per week column. I'll write down census. Here I'll give in the name of the column, which will be hours per week, and here I'd want to know the mean value or the average value. It comes out to be 40. So on an average, these folks work around 40 hours per week. And if I want to find out what is the maximum anyone works, so it seems that there's one guy who works around 99 hours per week. Then we'll have a look at the categorical columns. So we have some of these categorical columns over here. We have the race column, income column, sex column, and the work class column. And I'd want to know the frequency of these categorical columns, that is the value count of these categories. And for that purpose, I'll use this method called as value counts. So let me just go to Jupyter Notebook. I'll show you what we'll be doing with this value counts method. So I'll have census over here. And here, let's say if I would want to understand the distribution of the population, I'd want to know out of these data frame, what is the male population and what is the female population. What I'll do is I will pass in this sex column inside this. and I will find out the value count. So here I'll have value, I'll have counts. Let me run this. You would see that out of the 30,000 entries, so out of this entire population of 30,000, 21,000, so the male population is 21,000 and the female population is only 10,000. So it would seem that the male population is more than double than the female population. Now similarly, if I want to understand let's say the different about the different race, so over here what I'll do is I'll have census. Inside this I'll pass in race and I'll use value counts over here. Now when I hit on run, you would see that out of the 32,000, 27,000 people are white. So it's almost 90%, almost 90% folks, almost 90% of the population is white. Then we have only 3,000 folks who are black. Then we have 1,000 folks whose race is Asian Pacific Islander, and then we have only 311 folks whose race is American Indian Eskimo. Then we have around 271 folks who belong to other races. Similarly, if I want to understand about the marital status, let me go ahead and do that. So inside census, I'll pass in marital status over here and I'll use value counts. Let me hit on run. So here it would seem that out of the 32,000 population, we have we have around 15,000 entries where this category is married civil spouse, which would mean that this person is married and is mostly he's a civilian and he has a spouse. Then we have around 10,000 people who have never married. We have 4,000 people who are divorced, and we have around 1,000 people who are separated. So again, this is some basic information over here. Then what we'll do is we can also go ahead and change the name of these columns. So here, let's say instead of work class, because this doesn't really convey much of the information, if I want to change the name of the column, I have this rename method. So I'll give in the name of the data frame, then I'll use rename. So when I have census.rename, here this takes in two parameters. The first parameter will be columns, and I'll give in a dictionary over here. And this dictionary has key value pair. The key is the column which I'd want to rename. The value is to that particular value which I'd want to rename. So here I'll pass in work class and I'm renaming this to employment type. And I'll set in place is equal to true. In place is equal to true basically means that all of the changes directly happen in the data frame. Similarly, I'm using the rename method to change the name of this hours per week column to hours worked. So let me go ahead and rename these two particular columns over here. So I'll have census, I'll use the rename method over here, and inside this I'll have to give in this particular parameter which is columns. I'll have a dictionary over here and I'd have to give in the name of the column which I'd want to rename. So we had the work class column, so I'll just pass in work class over here. I'll have work class and I'd want to rename this to employment type. Then I'll just set in place is equal to true. Let me hit run and let me have a glance at the first few records of it. So I'll have census.head, and you would see that I have successfully changed the name of this column from it was work class, and I have changed that from work class to employment type. So this was about how can we rename the columns. So guys, unfortunately we are done with today's time. So even though we are not done with the case study, what we'll do is we'll have another live session scheduled, part 2 of it. So in the second part we'll cover this case study comprehensively. So I apologize for stopping the live session right now because we are limited on the time constraints. We are done with the 1 hour. So whatever is left in today's session will be covered in the next session, in the continuation of this. And before I sign off, I'd like to again tell you guys about Great Learning Academy, where you have all of these courses with respect to a lot of domains. You have courses with respect to data science, artificial intelligence, cloud computing, digital marketing, stats, and a lot more. And all of these courses are, curated by industry experts, and once you complete these courses, you will get a certification. You'll get a certification which you can go ahead and add onto your LinkedIn page or onto your resume, which will be your value add to you guys. And if you want to learn through an app, you will be able to, you'll find the link for the app as well in the chat. And also, if you haven't yet subscribed to our channel, go ahead and subscribe, and also hit the bell icon, as it will encourage us to come up with more such live sessions on a regular basis. And also, you will be notified whenever we have new live sessions. So please do hit the subscribe button, please do click on the bell icon, and also if you're interested to share it with your friends or share it with your peers or colleagues, go ahead and do that. Spread the word of mouth about great learning, and just spread the knowledge around. Let other people upskill themselves during this lockdown. So guys, thank you very much for attending the session. I hope you guys are safe. Thank you very much.